How's it going, guys? This is Joshua from Motiva Online Instructors. Today I'm going to talk about the University of Puerto Rico, Cayey, Precalculus Olympics 2007. Question number 1 states, determine the values of the constant m for which this set has exactly 2 elements. Now notice that the set consists of 2 quadratic equations, okay? And because it consists of 2 quadratic equations, I'm going to use the quadratic formula, right? Because these quadratic equations equal to 0, so I'm allowed to use the quadratic formula. Now let's use the quadratic formula for the first one. It says negative b, which in this case is negative m, so negative b will be negative m plus or minus b squared, the square root of b squared, which is negative m squared, minus 4a, which is 1, c. But here c is this whole thing, m minus 1. Okay? Divided by 2. And this is our roots, right? So negative and negative, it's positive. So we have m plus or minus the square root. Negative m squared is m squared. Now we distribute this minus 4 with this, and we have minus 4m plus 4. Everything divided by 2. Now notice that inside the square root, we have this another polynomial, but this one can factorize into m minus 2 squared. Okay? Now, by definition, the square root of m minus 2 squared is equal to the absolute value of m minus 2. Over 2. Now, because of the plus and minus, we're going to have 2 cases. So, when m minus 2 is strictly greater than equal than 0, which is equivalent to say when m is greater than equal than 2, then we have that x root is equal to m plus n minus 2 over 2, which is 2m minus 2 over 2. And if we divide 2 in both sides or factorize it 2, we are left with m minus 1. Now, when m minus 2 is strictly less than 0, or equivalently, m less than 2, then we use the negative 1. So we have that xr is equal to m minus n minus 2 over 2. Which is equal to m minus m is 0, negative times negative is positive, so 2 over 2 is just 1. Okay? Now let's do exactly the same thing for the next polynomial. So let's move a little to the right. We have negative b, which in this case is negative m plus 1, plus or minus b squared, which again is negative m plus 1, minus 4a, which is 1, and c, which is just m. Everything divided by 2. And again, this is the roots, right? So negative and negative is positive. The square cancels this negative, so I'm going to have m plus 1 squared minus 4m over 2. And now let's expand that square. So we have m plus 1 plus or minus square root m squared plus 2m plus 1 minus 4m. Everything divided by 2. Okay? And now let's simplify the inside the square root. M squared 2m minus 4m is negative 2m plus 1. Okay? And m squared minus 2m plus 1, like in the other example, the other polynomial, this factorizes into a perfect square as well. So this becomes m plus 1 plus or minus square root of n minus 1 squared over 2. And again, that's equal to m plus 1 plus or minus absolute value of m minus 1, absolute value, over 2. Okay? So let's do the same procedure. If m minus 1 is greater than or equal than 0, this implies that x root is equal to m plus 1 plus m minus 1. And m minus 1 greater or equal to 0 is equivalent to saying m is greater than or equal than 1. So this implies that the root is m plus m, which is 2m, 1 minus 1, which is 0, divided by 2, which is m. If m minus 1 is less than or equal than 0, which it's equivalent to say that m is less than 1, then the root becomes m plus 1 minus m minus 1 over 2. M minus m is 0, 1 negative, and negative is positive, 1 plus 1 is 2, so 2 over 2 is equal to 1. Okay, now why do I find this? Well, the reason is that now I have intervals to see this behavior. Here I have m greater than or equal than 2, here I have m less than 2. In this case, I have m greater than or equal than 1 and m less than 1. So we're going to unite all of these, okay? So that means I'm going to choose values. I'm going to write here the number line. And I have 1 and 2. And I'm going to choose values greater than 2. I'm going to choose values with 2, between 1 and 2, values in 1, and less than 1. And I'm going to see what happens with this polynomial and how they factorize. Well, let's recall that the polynomials are x squared minus mx plus m minus 1 equal to 0. So let's write that down. X squared minus n minus, what was it again? Mx plus m minus 1. Okay, so minus mx plus n minus 1 equal to 0. And the second polynomial is x squared minus m plus 1x plus m. X squared minus m plus 1x minus plus m equal to 0. Okay, now let's choose an m. This is the number line for m. Let's choose m greater than 2. So 3. So by this calculation, I'm going to have one of the roots going to be 3 minus 1, which is 2. And by this calculation, one of the roots is going to be 3 in this polynomial. So let's just verify that. Now we have x squared minus 3x plus 3 minus 1 is 2 equal to 0. And we have, this is the case for m equal to 3. And we have here, we have x squared minus 4x plus 3 equal to 0. Now, what does this factorize? Well, this factors x minus 2 times x plus 1. Oops. -1, sorry, equal to 0. This one factorized as x minus 3 and x minus 1 equal to 0. Now, notice that we have root 2 and we have root 3, but we have also root 1. So x equal to 2, x equal to 1. Here we have x equal to 3 and x equal to 1. And the set, the union of this set is what? Well, it's going to be 2, 1, and 3. And this has 3 elements. It doesn't have 2. So we already can discard values bigger than 2. Okay? Now let's check for values equal to 2. M equal to 2. So for m equal to 2, we have x squared minus 2x plus 1 equal to 0, x squared minus 3x plus 2 equal to 0. And this factorizes as x minus 2 times x minus 1. Oops, no. This is x minus 1 squared equal to 0. And this is x minus 2, x minus 1 equal to 0. Now notice this. The root here is just x equal to 1. And the root here is x equal to 2 and x equal to 1. So when I union these two sets, what do I have? I have 1 and 2, which has 2 elements. So we already found with m equal to 2, it satisfies the equation, but we're not done yet. We still have to evaluate between these numbers. So now let's find a value between 1 and 2, 1.5, right? So we have, let's see. Let me see if I already did this, because I don't, usually fractions are a little troublesome. So for m equal to 1.5, we have x squared minus mx, so it will be minus 1.5x plus 1.5 minus 1, which is just 0.5, equal to 0. And here I'm gonna have x squared. This one is m plus 1, so it's negative 2.5 x plus 1.5 equal to 0. Okay, now this doesn't factorize, it factorizes nicely. So what two factors of 0.5 when can I split them into so I can have 1.5? Well, for this one, I use the quadratic equation again. And the quadratic equation here will give me 1.5. And I'm going to do it a little faster because it takes a lot of time. 1.5 squared minus 4 times 0.5 over 2. This becomes 1.5 squared. You know what? Let's leave this one to the end because I don't want, there's too much calculations. Let's just go and calculate for m equal to 1. So for m equal to 1, we have x squared minus x plus m minus 1, which is 0. So this is equal to 0, and the other polynomial will be x squared minus 2x plus 1 equal to 0. This factorized an x and x minus 1 equal to 0, and this will factor into x minus 1 squared. So again, the set will be consistent with how many elements? Well, 0 and 1. So we found a second m that will make only 2 elements that will satisfy the equation. So let's finish with our last values. A value smaller than 1, which is 0. And I like 0 because it's easy to work with. So m equal to 0. We have x squared plus, okay, so it'll be x squared minus 1. Minus 1 equal to 0, and the other one will be x squared plus x squared minus x equal to 0. So this one factorizes as x minus 1 times x plus 1 equal to 0, and this will factor into x times x minus 1 equal to 0. So the solution set will contain what? Will contain negative 1, 1, and 0. So it has 3 elements in there. So we can't choose that set. Our last will be this guy again. Let's see if I can manage to calculate this. 1.5 is equivalent to what? 1 and 1/2. This is 2 plus 3 is 3/2. So 3/2 squared is 9/4 minus 4 times 1/2 is 2. 2 with 4 is what? 8. So this is 8/4, which is 1/4. Okay, so this is 1/4 over 2. As you can see, I don't believe in calculators. I usually like to do all the calculations by hand. 1.5 is 3/2, plus or minus the square root of 1/4 is 1/2 in absolute value. Just 1/2, sorry, over 2. These 2 cancels, so we have 3 plus 1 and 3 minus 1. So 3 plus 1 is 4, and 3 minus 1 is 2. Those are the 2 roots. And here, let me erase this. Here we have 2.5 plus or minus square root 2.5 squared minus 4 times 1.5 divided by 2. Now what's 2.5? 2.5 is 2 and 1/2, which is 5/2, sorry. So this becomes 5/2 plus or minus square root. 5/2 squared is 25/4 minus 4 times 3/2 is 12. 12 times 4. Wait. No, sorry. 3/2 times 4 is not 12. 3/2 times 4 is 6. 6 times 4 is 24. Again. So we're good. We're in the good side. Now we have 5/2 plus or minus. This is 1/4 again, so it's 1/2. The 2's cancel, so this is 6. And 5 minus 1 is 4. So we still have 4, but we have 2 and 6, which gives us a set of 3 elements. So in conclusion, finally, will be m equal to 1 and m equal to 2. So determine the value diagram for which this has exactly 2 elements, m equal to 1 and m equal to 2. And that's our answer, guys. Thanks again for watching. Please subscribe, like, share with your friends, and I hope you enjoyed this. Bye-bye.